Question 2, Newton's first law of motion. Check out the description box for more content in recordile for this September 2020 preliminary examination paper. Ungakhohlwa ukulike, ukushare nokusubscribe if ever you enjoy the content engicreate in this channel. So for now, asibonane nalo question 2, sibone ukuthi basibuzani ke. Now, question 2, but a woman is pulling a suitcase of mass 8 kilogram at constant speed up a ramp as shown in the sketch below. The ramp is inclined at an angle of 30 degrees to the horizontal, just like this. And she pulls on a strap with a force. Okay, there's a strap attached to the suitcase. Mhlambe udosa le suitcase ugibela ibhanoyi mhlambe uye Dubai. Uyabona? So le strap esilana kule suitcase, it makes an angle of theta. Then the kinetic frictional force on the suitcase is 1 Newton. Bese bathi ignore the rotational motion of the wheels of the suitcase. Ku 2.1 bathi define a normal force. Lana normal force la ku 2.1 singayidefine as the force or the component of a force which a surface exerts on an object with which is in contact with and which is perpendicular to the surface. Normal force is always perpendicular to any surface, and it's the component yani your force, right? Your force. This force this 51 Newton une vertical component as well as a horizontal component. So this component, this vertical component of the applied force, plays a role in giving us any normal force as well as the gravitational force. Now both of these forces, the vertical components of these forces, gives us any normal force, right? All right, now this is the definition. Lago 2.2, but draw a free body diagram. You always check your marks for this question. This is the normal force. I mean the free body diagram. You always do this. Check all I think you draw a puzzle like this. Always check ama marks wako. If it's 3, so yeah, okay, komele ngibe na 3 ama components. If it's 4 marks, komele be 4. Now let us count. 1, normal force ayisali, right? Sine applied force foot ubani 51 Newton. It's not sine, just like maths or sin. It's 51 Newtons. Then sibane frictional force, right? Fk, which is equal to 1 Newtons. Bese we sibanani the gravitational force, Fg. So these are the components while a free body diagram here together. Now 2.3, but is calculated with theta this angle theta. How do we approach this one again? How do we approach this one? So since left back the suitcase by dosa at a constant speed, it means that to F net equal to MA uyoba equal to 0. F net la uyoba equal to 0. The F net uzoba equal to 0, right? So since left back is being pulled up the incline, it's being pulled up the incline, the only forces is so I consider for F net, it's only the forces parallel to the ramp. It's this one. It's the parallel component ga FG parallel nobani na this component of the 51 Newton force, which is 51 cos theta. Then FG parallel FG sine le angle yala it's the same as this angle, which is 30 degrees. So kuyoba sine 30 degrees la, right? So if I'm choosing down as positive, so if I'm choosing, let's choose down as positive. La kuyoba ubani? Kuyoba plus 1, since the friction is going down. Kuyoba plus bani FG sine 30 degrees bese kuba ubani negative 51 cos theta equal to bani 0. I do have FG, so it's 1 lana, it's plus FG 8. FG, it's the weight of the suitcase, so it's 8 times 9,8 sine 30 degrees minus 51 cos theta. We have the formula I only have one unknown, which is ubani theta, so which is something enzo calculator. Let's punch this into a calculator again. 8 times 9,8 times sine 30, ngithola this 39. Okay, 39 plus 1 give about 40,2. 40,2 minus sine 51 cos theta. Then I transpose this one, this value, ngithola ukuthi it's 40,2 51 cos theta. Therefore cos theta uyoba equal to, I'm dividing both sides with 51, uyoba 40,2 divided by 51. Then theta uzoba equal to second function of cos, arc cos, uyoba 40,2 over 51 over 51. Theta uyoba equal to, so shift cos go about 40,2 divided by 51 divided by 51 divided by 51. Now answer here to 37,98 37,98 degrees. Now answer here to, right? So we thola kanje with theta wako. So the theta kwamele abe part of a formula in such a way ukuthi ungakwazi ukucalculate ubani, ungakwazi ukwenza lower theta the subject of the formula, which is something esiyenzile la, right? So this was just pure mathematics, ne? But setting up the formula was just physics. Alright, again, asiyela pa 2.4, determine the magnitude of the normal force that the ramp exerts on the staircase. Alright, okay. Now 2.4 sesifuna in the magnitude of the normal force. I think it's so. Normal force, in draw a free body diagram again. We're not going to be so well. 51 newtons. Then go about 1 newtons. Basically go about FG la. Right, we do have our components la. This is the component fx, then go about fy lo. Then go about fg perpendicular, let's go about fg parallel. All right, so for the normal, in order to find normal force la, right, I need to use our vertical components only, since ngifuna calculate ubani normal force, and normal force is in the vertical plane. So on the vertical plane we don't have any motion, right? We don't have any movement. So f net now yoba equal to 0. So f net is equal to 0 since there's no movement, right? So let's choose up as positive once again. So up is positive, it's plus n minus everything eya phansi it's going to be considered negative. So okay, another plus la fy, the vertical component for 51 degrees, 51 newtons I mean, bese kuba minus fg perpendicular, everything equal to 0. Normal force unknown plus fy, the vertical component ka 51 kuba 51 sine theta. Theta simcalculated sathola ukuthi it's 37.98 degrees minus fg yena its mass, it's 8 times 9.8. fg its mass times gravitational acceleration law 30 degrees. Since this one beku sine le kuyoba ubani cos ngoba it's the adjacent side to the angle ka theta, so kuyoba cos 30 degrees equal to 0. So normal force it's plus 51 sine 37.98 31.38 minus 8 times 9.8 cos 30 degrees is equal to 67.9. Yeah, 67.90 in 2 decimal places. Yes, equal to 0. Then the answer to go about what is 31.38 minus 67.90? The answer about negative 36.52. Negative 36.52 equal to 0. Then n is equal to 36.52. Now I answer it to newtons upward, right? Ngobi normal direction of the normal force is acting upward. Now Lago 2.5, the last question, but the pulling force on the staircase is now parallel to the inclined plane. How does this change affect the normal force calculated in 2.4 above? Increases, decreases, or remain the same? We need to choose. There's no reasoning, it's just choose. Increase, decrease, or remain the same. Nangabiyakushaye yovela udlala ilotho la piki mabelana then uta decrease. All right, let me explain kancane and then give you answer. If the force iba parallel, this force, meaning that I sub in an angle, yoba parallel like this, what's going to be the normal force? If lena say iba parallel, the applied force, it means that anyegi saba nama components, meaning that le value le it falls off, right? So sala not this one, right? So le value le nanangaba iseko kusala only le value le. We have got the normal force yosuka from 36.52 to 67.92. So the answer is it's going to increase. It's going to increase. Now the answer is question 2 with 2.5. Check out the description box for more content. I hope we enjoy it. I hope we told some value out of this discussion. Thanks for tuning in. Thanks for watching. Like, share, and subscribe. So for now, guys, catch me on the flip side. Now click on one of the links in the description box. For now, bye bye.